Simple tests for cations, AQA GCSE. We will start with flame tests, then move on to coloured precipitations with dilute sodium hydroxide, white precipitations, and then writing ionic equations for hydroxide precipitations. Flame tests for positive ions, cations. Take a clean nichrome wire, that's a wire made from nickel and chromium, cleaned by dipping in hydrochloric acid. Pick up a small sample of metal compound and place it in the corner of a hot Bunsen flame. There are 5 coloured flames that you are expected to recall for AQA GCSE. If you've done this already, pause. Can you remember the colours? So to resume, for copper, we get a green flame. Calcium 2+ ions gives us orange-red. Lithium gives us crimson. Sodium a yellow flame, and potassium a lilac flame. What would be the flame colour for a mixture of sodium and lithium ions? Well, flame tests or flame colour tests simply don't work for mixtures. Any distinct colour is obscured by mixing ions. Forming coloured precipitates with dilute sodium hydroxide. By adding drops of dilute sodium hydroxide to a metal ion solution, we get a coloured precipitate that is distinctive of a particular metal ion. For instance, Fe2+ ions, which may be referred to as aqueous ion 2 using the Roman numeral, forms a dark green precipitate. What would be the name of that precipitate? Okay, so that would be iron 2 hydroxide. So this is where the Roman numeral comes in. So the Fe2+ ion forms iron hydroxide, but we refer to it as iron 2, indicating the charge on the iron ion. Now, if we add further sodium hydroxide, an excess of sodium hydroxide, there is no further reaction. That is, this iron 2 hydroxide is insoluble. You are expected to recall these facts. Iron, being a transition metal, forms a differently charged ion, an Fe3+ ion, which we would refer to as iron 3. That will form a coloured precipitate with drops of sodium hydroxide, described as a red-brown precipitate. Pause and name that precipitate. Okay, I hope you've had a go at naming. Check your answer. Iron 3 hydroxide. We retain the 3 in the name to indicate the charge on the iron. So this is Fe3+ iron 3 hydroxide. As with iron 2 hydroxide, excess sodium hydroxide has no effect. That is, iron 3 hydroxide is insoluble. So both iron 2 and iron 3 are insoluble. Our third and final coloured precipitate in AQA GCSE is the copper 2+ or copper 2 aqueous solutions, which form obviously copper 2 hydroxide, a blue precipitate. As with the other coloured precipitates, An excess of sodium hydroxide has no effect. That is, the blue precipitate of copper 2 hydroxide is insoluble. Once again, you are expected to recall these facts. Moving on to the formation of white precipitates with dilute sodium hydroxide. The formation of white precipitates is slightly more complicated in that aluminium ions, calcium ions and magnesium ions all form white precipitates with drops of sodium hydroxide solution. So if we have an unknown solution of a metal ion and we add drops of dilute sodium hydroxide, we get white precipitates. That precipitate could be magnesium hydroxide, it could be aluminium hydroxide, or that white precipitate could be calcium hydroxide. Only one of these precipitates dissolves in excess sodium hydroxide. Do you recall which one? Okay, so to reveal, aluminium hydroxide, if we add excess dilute sodium hydroxide, will form a clear and colorless solution. So we can tell from the 3 white precipitates formed by magnesium hydroxide, aluminium hydroxide and calcium hydroxide, we can determine the identity of aluminium hydroxide by adding excess sodium hydroxide. If it dissolves, then the ion present in the original solution was the aluminium 3+ ion. So at this point, it's certainly worth reviewing. We've got 6 metal ions. Can you recall the precipitate color with drops of sodium hydroxide? Can you recall the effect of excess sodium hydroxide solution? Soluble or insoluble is the issue. Pause, do your best to complete the observations. Come back to check and correct when you are ready. Okay, so to reveal for calcium, a white precipitate, there's no effect of excess sodium hydroxide, it's insoluble. Fe2+, iron 2, dark green, insoluble. Fe3+, red, brown, insoluble. Copper 2+, blue, no effect, insoluble. Aluminium, a white precipitate once again, but this dissolves to form a colorless solution. Magnesium 2+ ions form a white precipitate, but this precipitate is insoluble. So there are 2 insoluble white precipitates, 1 soluble white precipitate, and then these distinctive colors. I'm going to give you 2 problems. I think they're worth doing at this point. How would you identify the metal ion present in a sodium compound? How would you identify the metal ion present in a magnesium compound? Pause, write out the description of what you would do and how you would conclude. Come back when you're ready to check and correct. So to reveal, for sodium, of course, we do a flame test. Clean a nichrome wire, dip it in hydrochloric acid, small sample, hot part of the blue flame, observe a strong yellow color. So the method and the result would be required. How would you identify the metal ion present in a magnesium compound? If you haven't had a go at that, pause and have a go. Otherwise, I'm going to reveal now. Dissolve the compound in water, distilled water, and add drops of dilute sodium hydroxide. A white precipitate would form. Add excess sodium hydroxide. The precipitate would not dissolve. That rules out aluminium. So the precipitate is not aluminium hydroxide, but it could be magnesium or calcium. You would then have to conduct a flame test on the compound. Calcium, of course, would give you an orange-red flame, a colorless flame, you would then conclude that that is magnesium. So you may need to combine, in the case of the formation of white precipitates, the analysis including a flame test. I'm going to show you how to write ionic equations specifically for the formation of metal hydroxide precipitates. So we're going to look at writing ionic equations for metal hydroxide precipitates, and the key idea is that ionic compounds dissolve in water to release their ions. So if we just look at an example, sodium hydroxide forms free aqueous sodium and hydroxide ions, which we write like so, Na plus Aq and OH minus Aq. Now, we can treat the reactions of the hydroxide ion separately from the sodium ion. If we look at copper sulfate, forms copper 2 plus ions and sulfate ions. Again, they are dissociated free ions. So we could just look at the reactions of the copper ion in isolation, ignoring the sulfate ion. So we can think of a metal hydroxide precipitation just being a reaction between the metal ion and the hydroxide ion. In other words, the metal ion plus the hydroxide ions go to form the metal hydroxide. And we could ignore the other ions, the sulfate ions and the sodium ions. They're not taking part in the reaction, they're spectating. So if we look at the symbol equations for ionic symbol equations for hydroxide precipitations, they'll follow a simple pattern controlled by the charge on the metal ion. So M is M for metal, N is the numerical value of the charge. Obviously, they're all positive. So Mn plus reacts with the same number N hydroxide ions to form the metal hydroxide, MOH N times. So the charge on the metal ion controls the balancing of the ionic equation. All other ions present in the solution, for instance on the previous slide, sodium and sulfate, you can just omit. They are not involved in the precipitation. Let's look at an example. Magnesium 2 plus. Well, we've got a charge of 2, so we need 2 hydroxide ions to make magnesium hydroxide, MgOH, twice. We're just following the pattern of the general ionic equation here. Now, in ionic equations, a slight complication, we add almost always state symbols. So I remind you, magnesium 2 plus was in solution, so that's Aq. Hydroxide was in solution, that's Aq. But magnesium hydroxide formed a solid precipitate, so that's S. Looking at that model, could you complete the ionic equation for the formation of copper hydroxide, including state symbols? Pause, come back to check and correct when you are ready. Okay, so 2 plus, so 2 hydroxides. Copper hydroxide is a solid. The hydroxide ion, of course, is a solution. Try aluminium. Write the ionic equation with state symbols. Pause, come back when you are ready. Okay, so aluminium 3 plus, we need 3 hydroxides to form AlOH3 as a solid. So aqueous, aqueous, and solid. So in this particular lesson, it's worth perhaps repeating the lesson until you are word perfect on the facts and the writing of ionic equations. And then, very important on this particular topic, to complete past paper questions from the AQA exam board. Other exam boards have variations, So it's very important in terms of question style and in terms of content. So make sure you're just answering AQA exam questions.